Right, we ready? Well, the big one, this one. So it's kind of like something you've never caught a fish before, and suddenly someone's explained to you all the components of how to catch a fish. Now you're going to actually catch a fish for the first time. And it feels quite good when you can do it, because you know that you've got the tool chain, and regardless of whether it's 2 output or 5,000 input or 5,000 output, the process is exactly the same. And I can see someone over there is already playing with that. Okay, so let's make a PCB. So the first thing we want to do, so we've got our circuit here. I recommend that you save it. I don't really care because it's so many things on my M drive, I don't bother, but you'll want to. I've saved to the pen drive, saved to the university drive. Make sure you've saved it before you do the next stage. The next thing that we're going to do, so this is multi-sim. There's another sub-package called Ulti-board. Now, Ulti-board is used to design a printed circuit board. This is why we like multi-sim, because multi-sim can talk to Ulti-board, written by the same software developers, and we've got the seamless thing from the drawing off to the actual manufacture of the printed circuit board. So, the first thing that I want to do is I go to transfer to Ulti-board, and the top option there, I don't know what the second one, oh, that's the file option, don't do that one. So transfer to Ulti-board 14.3, click on it, and it'll ask you to save it as something, and that's your choice, whether you put it up in the pen drive or whatever. And you're going to say, yes please, I'd like to save it. You see briefly that it opened up the Ulti-board icon, and you've got a series of net lists and so on there. And these are the components and connections that it's going to import into your printed circuit board. Do you need to note those or care about those? Not really, no. I mean, you would do if you're doing something more advanced and something was missing or something. But at this point in time, you just import it and just say, okay. Now, what have we got now? Well, what have we got now? We've got a yellow box, which is actually your printed circuit board area, and you've got your components which seem to be outside of the printed circuit board area. Well, they are. They are, because you've got to drag them in. So the first thing I'm going to do is I'm going to zoom in a bit just so I can see a bit better, and I'm going to very carefully select the component and drag it. And all I'm going to do is drag all these components onto the drawing area. Now when you pick up these pins, be careful that the box goes all the way around and isn't just highlighting the text. So I've got that pin now, and I can drag that pin. I haven't got that pin, I've got the centre of it. So here I still haven't got that pin, still haven't got that pin. And I've got the writing on it now. Now I've got that pin because it's highlighted the whole lot. Okay, so I'm just going to drag them in for the time being. Just get them into the drawing area. Like I say, this is tedious sometimes. You can do it better if you zoom in. Drag him in and drag him in. Right, so what I want to do is I want this to look something something like the printed circuit board, the layout that I had in the previous drawing, right? So, how am I going to do that? Well, if you go back to your original drawing, you can see that J1 was on the left-hand side. So let's just drag that across so J1 is on the left-hand side. Let's put the resistor here. So I'm just making it look similar to the original drawing. So I want to rotate that. That's orientation. I want to go counterclockwise, that's grand. Put that up there. Notice that I've now got R1 upside down, but I can play tricks with that, so I can click on that, right click and rotate 90 clockwise and then rotate 90 clockwise. So I mean, these are all things that you just find out for yourself, pretty easy, right? So jumper 1 is the input, jumper 3 was one of the outputs, so let's move that to the output position. And lo and behold, we've got that. things are starting to look up now, but we can see the wires are crossed on that capacitor, so we've got to do something about that. So we've got to flip that up the right way. So, orientation, 90 degrees counterclockwise, and again I'm going to do the same again, so 90 degrees counterclockwise, and drag that up there to make it look a bit neater. And it was jumper 2 was the input, jumper 4 was the output, so I'm just going to drag that across there, like so. And so now we're doing the settings. So now this is what our board will look like. I'm just making it look pleasing for the eye. So I think my J1 is too far away, so I'm going to bring that in a little bit to make it look a bit nicer there. I want the 2 input pins to line up with one another. So I'm going to drag that across. You can see I've got crosshairs that help me get it aligned. Let's put that there. Let's move my capacitor up a bit. Again, this is just making things pretty. Making a printed circuit board is definitely an art form. And if you do it in the right way and it looks pleasing, people think that it's good PCB. So, somewhere there? I think it is. I think that is, you know. So all I did there was drag the components in, move them about so that they look something similar to what we saw before. And that is what's called the rat's nest. Not a nice thing to be rats. If you go to the rat's nest, you'll realise that they just dig holes in the ground in all sorts of random directions. But it's your interconnections. That's not a PCB. That's the logical connections that we're going to use to make up the PCB. Okay, I can see most people have got that. I'm going to carry on while we're underway, and we'll make the PCB and then we'll come around and help those who have got some difficulties, okay? So, something that I might want to do in a minute is there's a thing called an auto router up the top here where it says auto route. But before I do any auto routing, I really ought to declare where I want the copper. Now, I said to you before that copper can be on the top or on the bottom of the board, right? It's just a piece of fiberglass with copper stuck to it, effectively. Now, if I go to copper areas, copper layers, so I'm down the bottom here. Look, I'm wiggling my mouse above where it is. Copper layers, you'll see that I've got copper top is on, down in the left-hand side here. Copper bottom is on. Well, that will produce a two-sided board for me. I only want to make a one-sided board because this is a really simple design. So what I can do here is if I just click on where it says copper top, there's a drop down and I can turn it off. So that means copper top is off, copper bottom is on, but nothing's changed in the drawing. Why? Well, because I haven't done any routing yet. So what I can do now is I can go up to auto route here, I can say start, resume auto router, and now those tracks have turned red. That's a PCB. That's the difference. That being red means that that is a real thing. And if I want to see what that actually looks like in real life, what I can do is I can go up to Tools, go right to the bottom and it says 3D View. This is magic, because I can see what my board actually looks like. How about that? How about that? It looks like a PCB. What would one say about it? It's a bit wasteful on the material, isn't it? So I haven't very efficiently used the printed circuit board material, and that costs money. A little board costs pennies, a big board costs tens of pounds. So what I can do is I can go back into my design again, and what I can do here is I can actually modify the boundary. So I always find this quite tricky myself because it's a job to get hold of the boundary, if you see what I mean. But, so I want to get that entirely in the drawing area first. And I go to board outline along the left-hand side here. I click on that board outline, and now what I should be able to do, with a bit of luck, there we are. So now what I can do is I can take that board outline and I can make it a bit more economic with the material, right? So now that's a bit more sensible, isn't it? And we've got our board. The other thing that you can do, if you wish to do so, is you can actually click on that and delete it. And if you delete it, it means you don't have a board at all. But then what you can do is you can go up here and you can say place, and you can say a graphic, as long as you're in the board outline, and you can make your board circular, freehand, with people making heart shapes last year and all that kind of stuff. But I'll leave that to you to play with. So the board's done there. Now let's have a look at the 3D view. No, we need to refresh that. So tools, 3D view. Look at that, isn't that nice? You like that? I like it. So that's my printed circuit board. You'll notice that I've got what's called a silk screen, which is effectively they spray the writing on the top. You can have a silk screen on the bottom as well if you want. But you'll notice that the boards that I gave you for your metal detector, it's normal to write R1, R2, TR1 for transistor and so on, so that the person assembling it knows what goes in those holes. Same with the surface mount. You would write on there what the component is. Well, it's already done it for me. I can change the names if I want, but I'm happy with J1, J2 and so on. What I'm not happy with is I've put all this effort in and nobody knows whether you made it, I made it, or whoever made it. So what I'd like to be able to do is I'd like to add my own graphic to it. So the first thing I'm going to do here is place graphic and free text down the bottom there. And I've got a little company, or always had.